Hello friends, in this video we will solve some problem based on geometric meaning of zeros of a polynomial. As you know, zeros of a polynomial px are the x coordinate of the points where the graph of y is equal to px intersects the x-axis. In simple words, just plot the graph of the given polynomial px and focus on the x-axis and try to find the point of intersection of the polynomial with the x-axis. That intersection point will be zeros of a polynomial. So let's try to solve some problem. Here this is a graph of say polynomial px. Then you can easily see that this is the point where the x-axis is being intersected by this graph, by this polynomial px. So number of zeros is equal to 1. Why 1? Because the graph of the polynomial is intersecting the x-axis only at one point. Look at another example. Again, this is a graph of say polynomial px, and this graph is intersecting this x-axis on this point. See, this graph is also intersecting this y-axis, but we are only interested to locate the point of intersection at x-axis, not on y-axis. So do not confuse with the y-axis intersection point. So this is the single point. So again, number of zero is equal to 1. Why 1? Because the graph of the px is intersecting the x-axis at only one point. For this graph, just count the points, number of points where the graph is intersecting the x-axis. You will find that this is the one point, second point is this one, third point is this one, and fourth point is this one. So number of 0 is equal to this time 1, 2, 3, 4, because the graph is intersecting x-axis or x coordinate at 4 different points. That's why the number of zeros will be 4. For this curve, you find that this is the point of intersection on the x-axis, and this is the another point of intersection on x-axis. So number of points where the graph is intersecting x-axis is 2. So number of 0 will be equal to 2. Similarly, look at this graph. Just locate the point of intersection of graph with x-axis. So this is the one point, second one, and this is the third one. So it is intersecting the x-axis at 3 different points. So number of zeros will be 3. Now look at this curve. You find that the curve is intersecting, or not exactly intersecting, but it touches the x-axis at this point. So means you can say that when this curve is plotted on the graph, this point is the common point. So basically this point will also lie on this curve, and this point also lie on the x-axis. So this is the single point where you can say it intersects or it is touching the x-axis. Basically, the intersection means that the points must be common to both the graph and to the x-axis. Here intersection means that this graph has a point which is also on this x-axis. Okay, so that point is common to both, means x-axis and graph. That's why, since here it is crossing the x-axis, that's why it's intersecting. In this case it is not crossing the x-axis but it touches the x-axis. So basically concept is that this point is also satisfy this x-axis, this curve, and also it is lying on the x-axis, and you know that on x-axis the y coordinate is always 0. So when you put the value of this point in this the value of this point in this curve, you will get the value of this polynomial becoming equal to 0. So here it is 1, this is a single point, so number of 0 is equal to 1. Now we will solve some problem. Given question is that the graph of y is equal to px are given below. For some polynomials px, find the number of zeros of px in each case. Just I have solved some problem. Similarly, here I will also do some numericals. First graph is this one. You can see that this is the graph of a polynomial and this is the x-axis. But here you find that there is no point of intersection of this polynomial and the x-axis. Number of 0 for this case is equal to 0. Why 0? Because the graph is not intersecting the x-axis. Simple reason. Next graph is this one. So this is the graph of polynomial and it is intersecting the x-axis at this point. So this is the single point. So number of 0 will be 1. Next is this graph. Just locate the point of intersection on x-axis. This is a point, this is another point, this is another point. So number of point of intersection on x-axis is 3. So number of 0 for this polynomial will be also 3. For this curve, you find that this is the point where the graph is intersecting x-axis and this is the another point. So number of 0 is equal to 2 because the x-axis is being intersected by the graph on 2 different points. Next is this graph. You find that this is a point, this is also a point, this is another point. So you have 3 points. So here number of 0 is equal to 3. And finally we have this curve. For this you can find that this is one point, this is another point, this is again another point, and this is the last point. So these are the points which are being intersected on the x-axis by the given curve. So number of zeros is equal to 1, 2, 3, 4. Since it is intersecting at 4 different points, so number of zeros will be 4. Next, we will see the relationship between zeros and coefficient of a polynomial. So first, we will take linear polynomial. As you know, the standard form of a linear polynomial is like ax plus b, where a can't be 0. So this is a standard form of linear polynomial. So as you know, if you want to know the 0 of a linear polynomial, what you need to do, just equate this ax plus b is equal to 0. So while you will equate ax plus b equal to 0, what you get? You will get x is equal to minus b by a. So here you find that the value of x is somehow minus b by a, then this polynomial value will become 0. Means that value of x will be 0 of this polynomial. Let's try to understand this with the help of an example. Say you have 3x plus 6. If you compare this standard form with this one, you find that a is equal to 3 and b is equal to 6. And you want to know the 0 of this polynomial 3x plus 6. So what you need to do, just equate it with 0. So 3x plus 6 is equal to 0. Why we are equating it with 0? Because we want the value of this polynomial to be 0, and for that we will get some value of x which will satisfy this condition. So solving this, we get x is equal to minus 6 by 3. So x is equal to minus 2. This means if the value of x is equal to minus 2 will be put here, then the entire expression value will become 0. And this x is equal to minus 2 you can directly find with the help of this formula, means which is a relation between coefficient of the given polynomial to find the 0 of a polynomial. Let's try to solve this with the help of this formula. See what happens. Since a is equal to 3 and b is equal to 6, so what you will do, I am writing here, you will write x is equal to minus b. So b is 6, so minus sign 6, and what a is 3, so you will write a. So this again comes out to be 2. So this is the relation for a linear polynomial between zeros and coefficient of this polynomial. For a linear polynomial, it is quite simple to get its relation between zeros and coefficient. Next is quadratic polynomial, for which we will try to find the relationship between its zeros and its coefficients. So standard form of a quadratic polynomial, as you know, ax square plus bx plus c, where a can't be equal to 0 and a, b, c are any real number. And you know this a is the coefficient of x square, b is the coefficient of x, and c is a constant term. So let's understand with the help of an example. Say you have a polynomial px is equal to x square minus 4x plus 3. So first you need to factorize this quadratic polynomial by splitting its middle term. Its middle term is this minus 4x. So let's try to split its middle term. So x square minus 3x minus x plus 3. So basically what I have done here, 4x is splitted in two terms, that is minus 3x and minus x. Taking x common, you find that x minus 3, and here taking minus 1 common, you again find x minus 3. So finally you have x minus 3 into x minus 1. It means the value of this px, which is x square minus 4x plus 3, is 0 when either x minus 3 will be equal to 0 or x minus 1 will be equal to 0. Why so? Just put 0 in place of x minus 3. The entire expression will give you the value 0. And similarly, put x minus 1 is equal to 0. Again, entire expression will become 0. So in another way, you can say that x minus 3 is equal to 0 or x minus 1 is equal to 0. And when you will solve this, you will get x is equal to 3 and here you will get x is equal to 1. So 3 and 1 are zeros of the polynomial x square minus 4x plus 3. This is 1 0 and this is the another 0 for this polynomial x square minus 4x plus 3. Now let's try to find the relationship between these zeros 3 and 1 and the coefficients. So coefficients, if you compare here x square minus 4x plus 3 with this standard form, you will find here that I am writing here in a separate box. Here you will find that a is equal to 1 because here nothing is written, this is 1 here, so a is 1. Similarly b, here sign is plus but here sign is minus, so overall b is minus 4, and since c is a constant term, here the constant term is 3, so c is 3. We will see the sum of its zeros. So 3 and 1 are its zeros, so what will be its sum? 1 plus 3, this will be 4. And also you can write in terms of its coefficient that minus of this b's values means the value of b, so you can also write it minus into b's values is minus 4, so minus 4 divided by a's values, so a value of a is 1, or in words you can also write minus times coefficients of x divided by coefficients of x square. So basically what I have written here, coefficient minus times the coefficient of x. So what is the coefficient of x here? Here the coefficient of x is minus 4. So minus times minus 4 will give you positive value and divided by the coefficient of x square. So coefficient of x square is here 1. So minus into minus 4 divided by 1 will come out to be this 4. Another relation is product of its zeros. So the zeros are 3 and 1, just take its product. You will find that its product is coming 3 into 1 is 3, and you can also write this 3 as the constant term is here 3, so 3 divided by this value of a. Okay, this is written in terms of coefficients, and in words you can write it constant term divided by coefficient of x square. To make a generalized form of the sum of zeros of a quadratic polynomial and product of its zeros, what you can do is that I am writing here in a separate box. Say you have ax square plus bx plus c, where a can't be 0. Suppose it has two zeros, one is alpha and second one is beta. Don't confuse with these two words alpha and beta, these are like variables. As you know, x, y, z is variables, so also alpha and beta are like variables. So since alpha and beta are zeros, so sum of its zeros, you can write what is the sum of zeros. That will be alpha plus beta, and that is minus coefficient of x. So coefficient of x here is b, so but minus times, so minus b divided by coefficient of x square, divided by coefficient of x square is here a, so that will be here a. Similarly, product of its zeros means alpha into beta, that will be alpha into beta is equal to constant term divided by coefficient of x square. So what is the constant term here? C, that is C, and coefficient of x square is a, so this is a. So in general or in short, you can remember this to directly find the relation between zeros and coefficients of a quadratic polynomial. Right now, you have seen that for a quadratic polynomial ax square plus bx plus c, where a can't be 0, you have alpha and beta as their zeros. So sum of zeros will be alpha plus beta, which is equal to minus b by a, and product of zeros will be alpha into beta, and that will be equal to c by a. So here one tip that I want to give you is that, say, since alpha and beta are zeros of polynomial ax square plus bx, this means x minus alpha and x minus beta will be the factor of this polynomial bx. Okay, factors of polynomial ax square plus bx plus c. Why it will be factor? Because when you put x minus alpha is equal to 0, then you will get x is equal to alpha. So since alpha is the 0, similarly when you put x minus beta is equal to 0, then in that case you will get x is equal to beta, and beta is also the zeros of this polynomial. Since x minus alpha and x minus beta are factors of the given polynomial, you can also write that, or you can also say that the product of these two will give you value equal to this one. Why I am saying this? Say 4 and 3 are factors of 12. So it means you can take the product of these two and you can write it equal to this one. So based on this concept, what you can say, ax square plus bx plus c will be equal to k times, okay, k times x minus alpha into x minus beta. Here I am writing k, which is a constant. Here I will write k is constant, because you don't know the exact values of a, b, c and alpha and beta, so you need to put a constant. Just solve this. What you will get, x into x give you x square minus alpha into x, alpha x. Similarly, x multiplied by minus beta will be minus beta into x, and minus minus plus, and alpha into beta will be alpha beta. just arranging the terms, you will get that k times x square. Here you can take x as common. So after taking x as common, what you will have, x plus beta, which is in bracket, times x plus alpha times beta. Just by multiplying this k with all terms, you will have k into x square minus k times alpha plus beta times x plus alpha beta multiplied by this constant k. So this is the right hand side expression, and in the left hand side you have ax square plus bx plus c. On comparing left hand side and right hand side, what you have, you will have a is equal to k, because here coefficient of x square is k, but this side coefficient of x square is a. Similarly, b is equal to, b is the coefficient of x, here the coefficient of x is minus times k into alpha plus beta, and constant term here is c, and that constant term here this side is k times alpha into beta. After getting all these coefficients, you can find the same relation, or you can compare. Sometimes in a question you are not directly given a polynomial which is quadratic, but it is given that zeros are, let's say, 3 and 2, and you will be asked to find quadratic polynomial. So in that case, what you will do, since here what we have done, alpha and beta were the zeros, similarly here 3 and 2 are zeros of a quadratic polynomial. So based on this concept, you can say, and also taking the help of this one, you can say x minus 3 and x minus 2 are factors of the polynomial, factors. So you can do that x minus 3 into x minus 2 and multiplied it with a constant k. This will give you the required polynomial px. For different value of k, you will get different quadratic polynomial px. So sometimes the reverse in question can be asked, that zeros are given and you have to find the required quadratic polynomial. So in that case, you need to do these steps. In the next videos, we will find the relationship between zeros and coefficients for a cubic polynomial. So thanks for watching.